easily. Maybe like a part of the actuation could be like a prep stage if there are cans stacked up in the chute, so that they're easier to crush once they get into the main compartment. And then like undoing some of the simplification that we went over earlier, so there are like more machining operations, and we can get more experience through that. And then our next steps, pretty much just as we had in the first Gantt chart, we're kind of past developing the concept, finding the design, obviously. The design is pretty much prepared in CAD, so now we're getting into the CNC planning and program preparation stage. And that concludes our presentation. Any questions?
Anything immediate from the group that you guys noticed? Is it too hard, too easy? All right, so I actually had a question. You said that you decided to change that from that cage design to the
solid wall,
the box instead of the cage.
Yep.
So if the customer had to have it be a cage instead of a solid box, I agree that would be difficult to billet machine. So how would you make that if you weren't going to billet machine that?
Well, we could construct a cage by like bending wire and then maybe like tack welding it or something else.
Any other questions? You guys think this is a good project? Make a can crusher? If you crush the cans, you can't return them, right?
No.
Okay. Just checking. Some states, they just take them like as recyclable.
Yeah,
aluminum.
no.
But
Massachusetts, you have to scan the barcode.
Yeah. So what's the value of crushing the cans? Just fun?
Fun.
Okay.
In fact, that'd be like a stress relieving thing.
Oh,
it's some cans.
Oh, it's like a fidget tool.
Yeah, I know my mom hates returning the cans, so she was just like, yeah, we're not saving these anymore. So if I got her this, maybe she would relieve some stress from work.
Yeah, I just leave mine out on the curb because I figure that's my
Yeah.
donation to charity this week.
Yeah, there you go.
You could also use it for like soup cans potentially, because I don't think you can return those.
Yeah.
So
Yeah,
I think
those you recycle. Perfect. All right, so can we get group 2 to stroll up there? And while you're doing that, if you're waiting, you can take some time to just quickly hit the Canvas site and do those quizzes, so that you don't have to do them later. So there was the intent was that there'd be some time between the presentations, so that you can do that. And yeah, it's perfect.
Is that a 10? Is it scale of 1 to 10?
Oh, it's scale of 1 to 10, yeah. I think as long as you're consistent in the scale you use, it'll work out.
Yep.
Because you get credit for submitting it, and then I factor in what your feedback is to the group when I'm figuring out what their grade is, like your analysis.
The buttons. Do I hit the buttons? All right, hold on.
Oh, wait, sorry. What were the names of the three that just presented?
Just like
Water.
the buttons.
Oh,
and then I'll hit the
Yeah, it's graffiti.
I was like, who else?
Ryan.
Okay, I was using
Perfect. Yeah, that's because we want to make sure that everybody in each group gets a chance to present. Actually, I think we require that everybody in each group presents. So when you're doing the presentation, just introduce yourself also, so that Hayden can copy that down. Yep, we capture it on video.
Hi, we're team 2. I'm Jackson. We also have Grace, David, Noel, Shane, and Ben. Grace. So for our project goal, we want to create a chess set. So a 64 square board with 14 pawns, 4 rooks, 4 bishops, 4 knights, 2 queens, and 2 kings, preferably in 2 different metals.
So, our reasoning for wanting to do this project is that chess pieces can be like really easy to turn on a lathe and can experiment with. And we wanted to like part of our project. We definitely wanted to experiment with like tolerances, consistency on kind of like the same design, but then also experiment with making other like figurines on CNC machines. So kind of the chess set combines those two ideas pretty well, and so that's kind of why we picked it. So.
We had a few preliminary concepts.
So the left one is what one of the group members already. Oh, and the two on the right are the designs that we put together so far in CAD. And then this picture was just like a inspiration picture on like where kind of we wanted to guide our future CAD designs and like just kind of think about how we would CNC this stuff. So this is just a materials like potential materials list, and kind of wanted to ask you like what our budget it would be. That would be like one of our only concerns too. There's also like clear polycarbonate from like when we're on stock. That's also like within reason for price.
What's your diameter? 1 inch?
Yeah, we're
Yes.
thinking 1 inch.
Yeah, and then concerns would just be like, what's our budget?
Yeah, storage involved, any of these things. Yeah, just kind of, we haven't come up with a timeline. We kind of went back and forth with the idea of like this being our CNC project versus this being our final project. And I think we decided on if it was our term project, we'd do the whole chess set. And if it was just the CNC, maybe we just try to mass produce some pawns. Just a simple project.
I don't have any questions.
Any questions from the group? So this is your chance to both provide feedback to them about how you think their idea is, maybe ask a question that would prompt them to think about something differently.
You listed anodizing as a concern. Would you expand on that?
I forget who had said anodizing. I think that was to do with just like a finishing process we were looking at.
Like depending on what material.
Yeah, depending on what material we'd use.
It's also like cheapest.
I mean, you could easily get two colors that way. So you
Right.
could make all the pieces with one material, and then so if you use aluminum, say you make all the pieces out of aluminum, and then you could anodize some of them black and some of them white, or I mean not white, but
Right.
there's different colors in the anodizing process.
So if we wanted to do that, that was kind of a concern. If we wanted to do that, we'd have to figure out how to do that first.
Yeah, and so there are companies around here that would do that for you. You could figure out what the cost is. My experience doing short part runs of small parts like that is that you're going to be at the minimum charge for just the setup for each color. Some small plating shops might, if they're already going to do some other parts of that color, they might throw your parts in with that batch and give you a better deal on that. And lead time on the small batch anodizing around here locally is probably going to be about 2 weeks. So if you actually wanted to get it done by a certain date, then you have to factor in that lead time. That's my feedback on the anodizing. It's probably easier to just go with 2 different materials,
Right.
so we get the 2 colors. So if you quickly go back to the slide where you had the different chess pieces. So this one, yeah. So there's certain pieces that are very well suited to turning on the lathe.
Right. Yeah, some of these would be hard to turn
If-
only on a lathe.
If you're gonna do this as your term project instead of just a short CNC project, I would suggest that you plan to do it on the ST30. And the ST30 that we have actually is a mill turn machine, so that it will do the turn features, and then you can come in and you can do milling operations while it's still in the lathe shop.
Cool.
And I think this project is really well suited to doing that because it also has a
Yeah.
bar feeder. So you could actually like make the pieces one after another in
Right.
the program. You could
That's-
spit out a chess set one piece after
That's
another.
kind of what we were hoping to do with
And
this.
so if you did want to gear this towards your term project, I would recommend doing it that way. We've got some resources to get you moving in the right direction there.
Sweet. Do you have a question?
Yeah, if you wanted to get around, like trying to anodize parts,
Yeah.
if you made them like all out of steel, per se, you can, there are like heat treating processes that will change the color.
Right,
You
yeah.
know, and then you wouldn't really have to do anything
Right.
very specialized.
Right.
You make all of them out of the same material and just heat treat half of them, and they would turn like a bluish color.
Yeah.
So
That's a good idea.
Professor, do you know how we would get stock? Because that was a big concern with our meeting
for-
yesterday.
This stuff, we'll have that around. We can help you out with stock.
Okay.
I would stay away from the plastic.
Yeah.
I would stay away from the plastic for a couple of reasons. We don't like to cut plastic in our CNC machines because,
Drives it out.
especially when you make small chips, those chips tend to get through the filters in the coolant system, but they clog up in the elbows in the coolant system, and so you'll have somewhere deep underneath the sheet metal, you'll have a blockage where the coolant won't pass anymore because those chips got through the filter, but not through the thing. So it's one of the reasons we don't like plastic. The other reason we don't like plastic is because it's hard to hold. It tends to be slippery and it tends to be very compressible. So when you try to overcome the lack of friction with more clamping force, you change the shape of it. Gotcha. All right, I guess we can move on to group 3. And while you guys are doing that again, the intent was that we'd have a few minutes here to go through the quizzes on Canvas while we're doing the presentation, so you don't have to come back to it later. You don't have to remember some comment. Imagine in order to give somebody a comment, you're gonna have to watch the video of them presenting again. So you even just take some notes now. Because there's 2 questions that are gonna come up with each presentation that you've got to answer in those quizzes. One of them is what's a question that their presentation arises in your mind, and the other is what's one piece of feedback. I'm hoping constructive feedback for the group, or it could be for the group or for the presenters. And if you see me futzing with my phone, it's just because I'm checking to make sure the YouTube thing is good. You guys are good. Cool.
Absolutely. All right, so good morning. We're going to be talking about our CNC project. We chose to go with a hand car, which we'll be just showing a picture of in a second. For the group members, we have Connor Sullivan, myself, Kyle Postins, Christopher Martin, Amber Lindbergh, and Bradley Sprunger. So for our idea, so for anyone who doesn't know, back when rail cars were really extensively used, there was something called a hand car, which was used to transport people on train tracks between different locations. So as you can see in the diff, it consists of a small linkage composed of a handlebar and a second bar connecting it to a gear, essentially like a 4-bar linkage. The gear transmits power from the handlebar to the wheel, which then moves the car along a track, or for what we might be doing along the ground. We chose it because it seemed like a really fun, relatively simple way to put machining into action while still being rather large and complex enough to be either a small-term, short-term project or a term-long project.
So in terms of the parts that we actually need to make this, we need the handlebar at the top that's actually being pulled, that's in orange, the link bar that's in blue that connects it to the gear, any pins or screws that we need to connect the bars or gears to the frame, the 2 gears, so you have green, and then that's the larger screw, which is going to purple, so we're getting more rotations per minute. the axles for the purple wheels, and then we wanted to make tapered wheels since on most train tracks to aid turning, wheels are kind of almost conical, and then the frame. So how we're going to make all of this, the handlebar and linkage bar can be milled, probably. The axles, the tapered wheels can be lathed. The pins or if we use screws to connect to the frame can either be bought or conceivably we can lathe the pins. The gears will be made using wire EDM and then we'll press fit them onto the axles. The frame we think will be milled and assembled, but I'll talk about that a little more later. Most, if not all, components can really just be made from something like 6061 T6 aluminum, which we have a lot of experience making parts out of in the labs. We're not sure necessarily what material is optimal or what can be used in wire EDM, which is one of our limitations. And the CAD for this likely isn't going to be too hard because almost all of these are really simple shapes. So in terms of our current challenges and what we want to figure out, only a couple of us have real mill, lathe, or Esprit experience through ME1800. None of us have ever used the wire EDM. So that's something we need to completely learn. And we don't fully know what the frame looks like right now since we don't have the CAD models. So aluminum might not be the optimal material. It might make it too heavy or too much friction. That's something we're going to have to figure out.
One more challenge to add up there that we didn't put up there would be the complexity of a project term versus a project versus a term long project. So this could easily fall into a term long project, not because of the parts that need to be cut out, but because of the actual assembly process and any complications that we run into. So there's obviously some limitations there between taking it from a project to a term long. You had a question?
I was wondering what scale you were planning on making it.
That was going to be my question too.
2 and 1.
So I think we don't want it to be a miniature, but we don't want it to be too small either. We probably want to constrain it to, I don't know, I'd say probably like in around an 8-inch cube. I know that the mills and lathes obviously kind of have a space limitation, so we can't make this thing giant, but ideally we'd like it to be big enough that it can almost be hand assembled.
Do you have tracks you're going to run it on?
Not currently, but we might find something to serve as it just for a test.
So that may determine your scale, right?
Yes.
If you go get like an H or an HO train set or get some tracks from a yard sale or something.
Yeah.
Maybe no yard sales in January in Worcester, but
Garage sets.
you could raid somebody's basement or attic when they're sleeping. Oh, did I say that out loud?
That Lego club has like some train track pieces.
Any other questions from the class?
Not a question, but you could just make the train tracks out of Legos.
One comment on, and this also might be helpful for other groups to hear. And I know you guys reached out about the gears and stuff, about making that in the wire EDM, which I think is a really good idea. For modeling the gears, because this is mainly like learning how to machine and everything. You might be familiar with like McMaster and stuff. You can pull the CAD models from there, the drawings, and use the dimensions from the gears on there. Because modeling gears is actually pretty difficult. So just pull it from there.
Thank you.
As an aside, I had somebody reach out to me in November wanting to create a startup company to make hand cars for a railway in Maine. So if you want to pursue this later after you've made your little model hand car, I will make the introduction.
That kind of sounds good.
He's an old retired carpenter kind of guy. This town in Maine and a bunch of abandoned railroad tracks, and he wanted to start something.
Thank you.
Which group were you guys?
Group
3. So group 4 is next. you guys are getting ready, I'm gonna get power to my computer. Anybody ever have those like recurring nightmares that you were like in class and you realized you didn't have your pants on or something like that? When I was a little kid, I used to have nightmares like that. Like I realized I was in school and I wasn't wearing, I wasn't fully dressed. I just saw that there was a mask in my bag here. And the first thing that went through my head was, oh shit, did I not put my mask on? I forgot my password.
Okay.
Have to do the quiz,
Oh, yay. I don't even.
So for any like material stuff, they should just reach out to us, right?
Yeah, so
If it's
for
not-
like for acquiring material for your projects, just reach out to myself or Hayden or James in the machine shop. And for everything I've seen so far, we probably have material laying around that'll work for you. And if we don't, we can help you acquire it. You guys ready?
Hello, we're group 4. I'm Heather Oxford,
I'm Robert.
Patrick.
and we're planning on making a root style supercharger. We're planning on modifying the model from the original CAD file that we found. We wanted to make this a little bit smaller, and also some geometry wasn't possible to machine, so we had to change some things. One of the things that we're going to be changing up is the case. We'll probably exclude this in the final product and replace it with like a top and bottom plate so that like the overall size of the assembly is smaller, and also there's less material that needs to be removed. And also we have to adjust the geometry because we can't machine the internal corners. One of the other parts is the counterclockwise screw. We're basing the size of these on the shaft diameter so that it's easier to find other parts that fit to it instead of making it a weird size. And this is probably going to be our biggest machining challenge because it's like a weird spiral shape.
Yeah, this is the other piece that meshes with that last one. It's just a mirrored geometry, similar manufacturer. I think that's the wire EDM you were looking at.
Yeah, we were thinking about doing this on a mill.
This is going to be
Axis.
a 5-axis or
I think four.
four for sure, maybe 5-axis
Yeah.
setup.
I knew there was a machine for it. I just didn't know which one. Yeah. And then we also need some spur gears. We're probably not going to machine these, either order them online or just 3D print them. I mean, PLA should probably do the job for that. It's not going to have much of a load. So, and then this is what we were talking about with like the top and bottom plates. We're not going to do the ribs just because, like we said, we can't machine those internal corners. It'll probably just be a pretty simple plate. Just front and back have like the gears here, so you don't stick your hand in, I guess.
Yeah, so as we said, we're going to do some modifications to the model that we found on the internet. The first and foremost is we're going to scale it down a bit. The original model we found used 20 millimeter shafts on the supercharger screws, and we want to scale that down to 10 millimeters. And then, as Heather mentioned, we want to remove the casing around the screws and just replace it with 2 vertical plates with pressed-in bearings on either end, and then have a crank so that the student or user can see the supercharger operate.
So this will be a demonstration
Yeah.
model, not a functional model.
Yeah, correct. So we've started looking at how we're gonna machine this.
Our initial thought is to use a axis on a milling machine with a ball nose end mill and set that up along X because it's an A axis, and just use one of Fusion 360 or Esprit's fourth axis programming functions. We also need to know what machine we're going to do this on. We need to know the tooling. I know when we played around with it in Fusion, we used a 3/8 ball nose end mill for the finishing pass. And then we need to know if we're going to need some sort of tailstock support to prevent it from chattering during the cut. And our roadmap moving forward is to get the idea approved, maybe receive some feedback on our design, and then figure out materials. We're thinking like a 6000 series or 2000 series aluminum for the screws, and probably just order shafts to press in to simplify the machining of it, and begin machining parts.
Any more questions?
I would just be careful with instead of 3D printing the gears, just tolerancing the 3D printing can be kind of a nightmare sometimes. So, I would just keep that in mind with that.
Definitely.
Mine will be eating through your ELA stock, so.
We could easily cut those on an EDM, or you can order them. Because that's not the critical part of your project in your mind. That's why you were thinking to 3D print it.
Mm-hmm.
You could extend that learn how to use how to program and use the EDM.
Yeah.
Which I think would be a benefit. So.
How did you guys decide on using a roots type blower?
I think a centrifugal type blower would have a.
Well, you
Impeller.
mean in general, how do you?
I don't know. We just sort of.
Somebody suggested it.
Yeah.
Yeah, that's cool.
It'd be a cool way to demonstrate fourth axis machining.
Yeah.
In a different type of supercharger or turbo with a impeller wheel would require 5 axis, and that seemed a little bit much for us. But
Group 5.
You guys want to come after class to go over this at some point, there.
He's got some experience manufacturing one of these.
Yeah. Would you like us to do the quiz for our own group?
Yeah, do the quiz for your own group too. That way there's none missing. You can feel free to give yourself, good grades or bad grades, depending on how you feel like you did.
Just a question. The quality questions out of 5 or 2?
I think it's out of 10.
Okay.
As long as you are self-consistent, I'm going to normalize people anyway.
Okay.
Before I apply their grade to the other people. So that's one of the things I always hate about these surveys, especially like class surveys, is I always kind of rate everybody pretty low. And so if you don't normalize mine against all of my past ratings, then you can't really separate the two groups. So we'll normalize it before we apply it to somebody else.
Gotcha.
Right.
You guys are good to go.
We are Group 5, our first project with CNC machining. I'm Brian, this is Sam. All with us, we have Lily, Nick Franzini, Brian Pacheco, and Tyson.
So some of our project ideas that we toyed with were an M&M dispenser, a chessboard with pieces, and some sort of puzzle. And we ended up deciding on a puzzle just because it will allow us to make a bunch of different parts with all different shapes.
Different considerations when we were having these ideas for a project. We were kind of teetering between term long or the 2-week project ideas, but we try to take into everything like M&M dispenser. We were thinking of maybe complicating it would be using gears, and machining gears was really difficult. So we didn't really know to carry along with that or not. Also taking into consideration whether it needed to be turned or milled. But with the chessboard, also with the small complex work pieces, we thought that would be tough with the tool geometries and maneuvering around small parts. Ideally, we came to use the puzzle as there's different challenges, whether we want to make it like a complicated puzzle or pretty simple, depending on if this is a 2-week again or a term-long project. And we thought that there's a lot of variability if we went with this puzzle, and it could also show different tolerances that we could extract.
So we're thinking that for the puzzle pieces, we're gonna make them out of aluminum, mostly because it's easily machinable and it's pretty readily available in the lab. So that'll help us be able to get going quickly once we have our designs. We don't have our designs as of yet, just because we wanted to get feedback first. So, feedback.
It's no engine, but it's
Yeah.
it'll be a puzzle.
Feedback from the class. Questions?
Have you landed on a type of puzzle design that you're thinking about doing?
Wait, what?
Have you landed on like what type of puzzle that you're thinking?
Oh, I think, well, depending on like like feedback and stuff, I think we were thinking more of like a 3D puzzle with just bigger parts and different linkages. I don't know if you like if we go back to the other slide.
Like something like one of those is what we were thinking.
I don't know if you guys
Interlock.
So not like the Da Vinci Code thing where you have to get the stuff out of the inside.
No, we could
You do something like that too.
do something like
Yeah,
that.
that's a good point.
That was our initial thought was something along the lines of this, different parts, but
Yeah, that's why we wanted to bring it to class, because we weren't quite sure which direction we wanted to go.
So, what do you guys think? You want a 3D model or a 2D model?
Yeah.
All right. So anybody that doesn't want a 3D model, put your hand up. All right. So
Looks
it's
like
going to be
we're
a
doing
3D model. See, if you
Perfect.
told us what it was, then we would just accept that. But since you told us you want feedback, we're going to now tell you what the customer needs are, right? So a 3D model.
should we like have like
How hard should it be? You know, should it like a 9-year-old be able to solve it, or do you want to make it simple enough like a 50-year-old can solve it?
32 and up.
32 and up. So pretty simple then.
Well, I
I'm
guess
pretty sure
I guess it
kids
does
are the
go
ones that
back.
solve the hard puzzles, right? Based on my experience at Christmas parties, it's the kids that solve the hard puzzles.
Yeah, and the other thing is we're probably going to look around if we can find some sort of existing designs.
Right, because this class isn't really about the
Right.
design per se. It's, I mean, it is to talk about design challenges for different operations, maybe. But I'm guessing that there's stuff out there on the internet that are designs for making these kind of puzzles in with like Instructables or something like that. Probably has some files.
Yeah,
So a lot of those Instructables files are intended to be 3D printed, right? And so you may have to make some design changes to convert it from something that's 3D printed to something that's machinable. So that could be your challenge there. Were you thinking that this would be like a 2-week project or a 3-week project, or were you thinking it'd be the whole term?
If we were thinking, depending on how many like pieces and steps it has, that would change depending on whether we do the whole term or the 2 weeks. So still to be determined, I think, depending on what designs we find that are existing.
But I think just
Anybody else from the class? Questions, comments, feedback?
You're gonna run into a lot of, I think this is a good project idea. I think definitely one of your biggest constraints is gonna be tolerances. That's gonna be, yeah, because a lot of these puzzles are gonna have weird right angles that you're gonna have to, you know, you can machine one way and then you're gonna have to flip it and do a different fixturing. So I think that's gonna be good to learn that, the different fixturing and how you can actually machine it.
Well, I think another thing about the puzzle idea here is you can make it so that there's a firm upper limit and a lower limit on those tolerances, because if you make it too, like a go no go kind of thing. So yeah, that could be cool. So I guess you guys are done.
Yeah, we're
Anything
done.
else for these guys? I'll talk for a little while, then we'll probably end early today, which is, I guess, a little bit surprising for me. I thought we were going to have to struggle to be on time the other way. Woo, that's kind of psychedelic if you see this screen. It's all lucky for us. I'm the only one currently watching. But I'm imagining some people are going to watch the video later. So let me stop the screen share. Yeah.
What's the difference between this January 20th assessment versus the group assessments?
Yeah. Give me just a second. Yeah, that's fine. And I'm gonna. All right. This is the one with the live mic. So I'll talk to this one. Oh, because this window's open. That's why. Because we're sharing all kinds of different stuff here. Mute. That's better. Now I'm not all confused. Screen up. Okay. All right. So you ask your question again.
What's the difference between the January 20th, just the assessment versus the group assessment?
The difference between the January 20th assessment and the group assessment, that is a valid question. Can somebody open up the January 20th assessment and tell me what the questions say?
Your group's performance.
So one of them's about your group. Oh, is one of them not a quiz? Is one of them where I give you feedback? No. I think the assessment thing is my feedback to you guys. Maybe.
I think the 20th assessment is your group's work for the week, but the other ones are for just the presentations.
Right. Yeah. The group by group one is just about the presentation. Then
the January 20th one is like us assessing our group for the last week.
Right. That makes sense. Oh, I get it open here. I can look at it. Yeah, I'm wondering if I made too many things. That's why I want to investigate this. Let me go to assignments. And so January 20th assessment. So 5 points. Rate your group's performance, rate your personal performance. Yeah, so this is like your assessment of the group as a group for the week. So the one that's called assessment. And as compared to what?
There's
So the other one is just the instance of the presentation. So in that one, you're just assessing the instance of the presentation. Yeah. Okay. So I didn't make too many things. I meant to make all those things. Yes.
The peer and self-assessments, both don't have quizzes or it's just submit something. The ones that are labeled peer assessment, January 20th self-assessment.
So self-assessments down here. They're like undated.
Yeah, they're undated.
Yeah, I see that. I can fix the dates on those.
And yeah, I don't see this. This is a submission button either.
Yeah, that's that's where that's just a column in the grade book. Oh, that's why they're not dated. That's where I bring together the information from all the other assessments and collate it for you and provide it back to you. So that's for me to give you, so because each person evaluated each group's presentation. So I collate like the feedback and the questions and stuff like that, put it together and then give it back. And so that's just a column in the grade book. You don't have to do anything for those. That's how you get information back. Yeah, I was totally on the ball with this class, and I created all those quizzes weeks before the term started. Normally, who has the ME1800? Like, I'm normally pretty bad about creating quizzes and stuff, getting them posted on time. And so I wanted to not be that guy this term. With this class, at least, I'm still pretty bad in ME1800. But now I can't remember what I did because I created it like a month ago. So we'll figure some of it out as we go. But the intent there is that you are active every week working on your project with your group and giving everybody feedback so that we're interactive. I just want to quickly review the 5 group projects here. So group 1, just remind me what your project is again. Can Crusher. Group 2.
Justin.
Group 3.
Car.
4.
Supercharger.
And you're trying to tell me and see if I can remember puzzle. There's a lot of stuff in here. It's good that I can bring that back to the top again.
LE.
Oh. No problem.
Yeah.
No problem at all. I got that. What was I going to say? Okay. Group 1, was this going to be a term project or just a quick project? Okay, it's a term. Group 2, same question.
Yeah, I think we wanted to make the chest set.
Group 3, same question.
Term project.
Group 4, same question. That's going to be a term project. You're not whipping that out in 2 weeks. I mean, it could totally be done. If you had the drawings, if you had all the design work done, you totally get it turned around in 2 weeks, but you don't. So I don't believe you're going to have it turned around in 2 weeks. And Puzzellers.
Probably term.
Term. That makes life simpler. For figuring out who's doing term project, who's not doing term project. All right, so that keeps us in the machine shop doing all of them involve CNC machining. So can crusher. It's pretty simple CNC parts, but they do have to fit together, work together. The chest set. So this will be mill turn. Right. Most of it's turning, but some of the parts need that mill turn, and you can bar feed with this too, right? And so those are some concepts that are really focused, or they're really common in production machining. So if you're going out there, if you're especially making turn parts, you won't see a company that makes a lot of turn parts unless they're all one-off parts that doesn't have a bar feeder attached to the end of their lathe. So the stock comes in, you cut it to bar lengths, and it just sits up on a rack, and it automatically feeds into the machine, and it just spits out parts all day long. And so this would be a really good experience for both programming, setting up the mill turn, and the bar feeder. The can crusher, those are all pretty much 2-axis parts, right? right? So it's all sort of geometric shapes that are. I mean, you could conceivably water jet or laser cut out all those parts and then assemble it together. Is that true?
Yeah.
I don't know. I'm just trying to remember what the picture looked like.
So the handles could be turning.
Yeah. Okay.
If we wanted to do the handles look like the brick molding as initially modeled.
So if you the way the picture with the molding, so that's like a 4-axis part, and I think that might be a good stretch goal for you guys to maybe make a handle that makes it function, and then try to make a grip and do a 4th axis thing for that. I got to remind myself this is a class project, not MQP. It's not a prototype part for a startup company. It's just a class project. So don't let me push you too far, but also don't. If it's too simple, you're gonna sit back and wait till the end of the term to finish it, and you're totally not gonna finish it. It's gonna suck, and you're gonna hate it. We're gonna hate it. It's not never any fun. Which is also why every week I want to do some progress updates on the project. And then depending on which week it is, I may have also assigned your group to research something and present that about the topic that we're covering for that week. And again, this is the first time I've done any class this way completely. I have done weekly updates on progress for projects before. That always results in better projects. If you have to report to the class, to the group, what the projects are. So I want to definitely do that. And then I believe that there's more learning if you learn something with the intent of teaching it to other people, and if you go out and seek that knowledge. So that was the intent of having these Thursdays be presentations, group presentations. Again, if you can't be here in person for the group presentations and you're the presenter for that week, and chances are that'll happen to somebody this term. And maybe you can switch who in your group does the presentation, but you can come on live remotely in this webcasting software that we're using. So just hit that link if you're at home. If you're just at home observing, you can type comments in the comment thing. So just go to the YouTube link if you're at home just observing. But I think so. This is mostly milling, turning, and maybe 4 axis, right? The hand car. What kind of processes does your parts need?
I think milling, turning, and wiring.
That's what I think too. And so that'd be cool. So you get and programming the wire EDM is super simple, so I've been told. I've only ever observed people do it, but I believe that it's super simple. So you should get that supercharger. This is definitely 4-axis plus milling and turning. And puzzle. So this is still up there. You're gonna have to, for the puzzle guys, you're gonna have to come up with the design, right? And I think you can. I mean, I think you'll be able to find something that's already got solid models for it. You'll probably have to figure out the drawings and tolerances for that. So, but what processes? So since you haven't found the design yet, what processes do you want to use? And then you can find a design that uses those processes.
Probably 4-axis would be pretty interesting. Because I haven't done.
Okay. Or 3. Yeah. Well, I mean, if you're doing 4, you're also doing 3.
Yeah, I haven't.
Yeah, I think it's actually great that we have a bunch of projects that have that need to do some wiring. I thought there was 2 groups that were making gears. Kid Crusher's going to do gears too, right? Yeah, so you get some wire here too. Okay.
Group 4 has gears in there, so we suggested 3D printing in our.
Yeah, no, you're not going to 3D print them.
Okay.
So we got to figure out how to get a wire on the chess set now, so that everybody does that. Or you guys, the lathe that does the mill turn is like opposite the wire ADM in the same room, so you'll be able to observe a bunch of wire ADM while you're making your parts. That'll be fine. So we've got processes figured out. What do you think the biggest challenge is for the can crusher? What's going to be the hardest part to do that? And not just for group one, but the whole class to answer the question. What do you guys think the hardest challenge is for that one?
Probably like tolerance again, so that like friction doesn't like undo all the force that you're putting in to crush the can.
And you're specifically worried about friction.
Well, or if it's just like if like the
Yeah, but so like if you've ever used like an old fashioned jack, where it actually just uses the fact that one steel plate is wedged against another steel rod, right? And they just go like that. So that so when the thing is, there's actually a name for that mechanism. And I did a consulting job where I designed a part using that mechanism, and I had to go do a presentation for the customer, and I looked up and I found out the name for that kind of mechanism, but I don't remember. But anyway, that kind of mechanism, you guys know what I'm talking about, that sort of ratchets up and down. There is a name for that. And so that phenomenon happening could be a problem when your parts are sliding up and down if they get a little bit crooked, right? So it's really alignment plus tolerancing, right? That's gonna, because you can solve that with having your sliders be able to swivel too. So, but it's that long range of motion that it has to go through, I think, is your challenge, right? So the motion. For the puzzle, what do you guys think the biggest challenge is? I'm trying to go in different order, so you guys don't always get stuck last.
I think the biggest thing is probably going to be like the tolerance thing, in the sense that there's with those 3D puzzles, there's a little allowance of space to get those pieces to fit in, and if we do use like a material like aluminum, there's going to be some rigidity to it. So I think fitting those pieces in, like disassembling and assembling the puzzle, I think is just going to be up to how well we machine the pieces.
Are you going to be able to use math to figure these tolerances out, or are you going to have to do sort of the make it and check kind of method? Science, we'll call that science, right? Is it going to be engineering or science more?
I think a mix of both.
What do you guys in the class think is more appropriate for figuring out how to make that puzzle thing work? Math or experiment?
I think experimenting to see things like which would be acceptable tolerances if it being too tight or such that you can't disassemble it, or if it's too loose, then it's going to be really easy and you could like wiggle parts that are unintended to be able to remove in a certain way.
So I think I want to challenge you guys in the final project. So by the end, you should be working on this as you go along, though, to define what the tolerances required were for the different parts. So I think you're right. You're going to need to do some experimentation to determine what those tolerances are. But it'd be really good if you could define them at the end. You had a question, comment?
If you were looking up online, what tolerances are usually done for like other puzzles? And
I think it would be worth researching it to see if somebody has published on it. I don't know that. Often I think, I'm going to go find that. I'll go look it up online, right? And if you can't find it, one of my friends, he was doing a project before he became a professor. He was doing a project for a company he worked at. And everybody knows that, like, when you put a coating on something, like you spray paint on something, you rough up the surface with sandpaper first, right? So he's like, well, we know that. And they were doing a spray coating on something, and he wanted to make sure that he had the best adhesion of his spray coating on the surface. And so he's like, well, I'll go to the library, I'll find some papers, it'll tell me exactly what's the right amount to rough it up to get the best adhesion. And then he has now spent the next 40 years of his career developing tools to help understand that phenomenon. Because it wasn't like that became the rest of his career because he couldn't find it in the library. It's one of those things like everybody knows you rough up the surface, therefore somebody must know how much you rough up the surface, right? But so yeah, I would look for it. One of the first things I learned in graduate school was that a few years in the lab could save you a few hours in the library. So definitely look for it before you do the experiments. But I think you're gonna have to do some experiments. Yeah.
I feel like something with the puzzle that would start out as like you're doing tolerances, like defining it beforehand, and at the end it turns into, all right, let's make this piece so it fits.
Yeah, well, I do think you're right. You're gonna have to have some target when you make the first parts. So you're gonna have to figure out some range that you think it's gonna be within, and then work from there. On the supercharger, what do you guys think the hardest challenge is gonna be on that supercharger? So you're confident you've got good designs for the gears that mesh together? I think so. Okay, yeah, that's good. So it's just figuring out the tool paths and setting up that fourth axis and getting good at, especially since you'll almost certainly use the VM2 to set up the fourth axis in. It's got the biggest footprint of all of our machines, and that's a very popular machine. So you probably won't get to stay set up in there for 2 weeks while you figure out all your problems. You'll have to get good at putting the stuff in, taking it out, putting it in, taking it out too. But he's an expert. Yeah. No, because we're going to give you the tailstock. I would definitely use the tailstock on that. So this is going to be a setup. Is really I think setup. Setup and programming is all sort of mixed together, but this is sort of setup. I think is the big challenge. So I want to challenge your group to really clearly define how that setup works and try to streamline that process so that if a future group is looking at that report, they'll be able to more quickly get to the point where you were. Does that make sense? Hand car. What do we think the biggest challenge of the hand car is? I think it's that we're going to wish that we made it big enough we can ride on.
Probably friction. I mean, there's a lot of moving parts, so ideally it moves. Also, manufacturing the frame might need to be done intelligently because it's the biggest single piece in our thing. So maybe we want to separate it, manufacture 2 parts of it, and then assemble the frame, or maybe there's a smarter way to manufacture it.
You mentioned when you were presenting that you were worried about the weight of the frame. Well, you could machine away. If you could make it out of billet aluminum and machine away most of it, so you could make it super light and have it still be billet machined if that's what you want. You had a comment?
Yeah, I was gonna say some of the linkages are gonna be pretty like skinny for how long they are, and if you're putting enough force on the handle to make the whole thing plus whatever weight's on it move, there might be a problem with like slop in the pin joints or just like actual bending of whatever the linkage material is. So it would have to be like some rigidity.
So you're worried about transmitting the force, right?
Because I was thinking worst case.
So that's sort of a materials and a design thing, right? So you can change deflection by changing the geometry. Yeah. What's the word? Was I? The moment of inertia. I know the formula. I just can't remember what the words mean. I can totally write the formula. But you can affect the geometry of the part to make it stiffer. You could also affect the materials that you use to make it stiffer. So you may have actually have to do some testing to figure out how much load do you have to put on that linkage in order to move this mass. And so there's some engineering, there's some math that you got to do. And then what do I design it out of in order to make it work? I guess the design part really doesn't have to be a big component of the project, right? Because the class is about computer integrated or computer aided manufacturing. So we're really focused on the manufacturing side. But as a manufacturer, and this happens a lot at our company, is people will ask us to make stuff that we can see immediately isn't going to work, especially prototype parts, especially with like inventor type people that have an idea, but they're not engineers. And what they really want is to have the part in their hand. They don't want to have done engineering, and they don't. So it's all those things. So as a manufacturer, it's good to be able to quickly recognize those kind of concerns and say, if I make this the way the customer asked for it, is it actually going to meet the customer's need? And then depending on who the customer is, you handle that conversation with them differently. But that sort of gets to the business side of manufacturing. We're going to stick on the process side here, but I think that is a really good point. So you guys may get challenged with that. What's a good thing to ask them to include in their report then? Like for this one, it's define the tolerances. For this one, it's define that setup. What would be a good thing to challenge that group with? It might just be about recognizing the feasibility of the design options, right? Because you're going to have a bunch of different options.
Yeah, we've already come up with some different like renderings for how we can make it move. So we could just throw out the linkage and try something else if that doesn't work. But we want to use the old style like design.
Yeah, I guess there's two questions to answer here. Is it about moving people down railroad tracks, or is it about copying the old style design? Because you could come up with a different mechanism if it's just about moving down railroad tracks. All right, and test set. I think the challenge here is going to be learning how to do the setup and programming for that mill turn operation, right?
And then
I can tell you that the bar feeder is add one line of code, so that's not that hard. You just have to know which line of code to add. But it's going to be setup and programming. Is there anything else that stands out about the project? If you had to pick right now, which one is going to be the best at the end? Based on your observations today, I guess you can abstain unless you were watching on YouTube. And the video is up on YouTube, so you can watch it later. You just missed the ability to view it live. If you had to pick which is going to be the best project based on what you've seen already today, how are we going to rate this? Hands up. I totally want to do like the cheering thing, and then we have an applause-o-meter and have it be like late night TV, but that's probably inappropriate. There's definitely a class on the other side of that door. Who thinks that the can crusher is going to crush it? So you guys, you have to vote for your own project. What we got? 1, 2, 3, 4, 5. All right, I get 5 votes for can crusher.
Can you vote for multiple projects?
I think you can vote for as many projects as you want. Right? It's like a poll on Facebook. But you guys know what Facebook is, right? Well, because the young kids today, I guess, are on the Insta, not the Facebook.
You have to use it for roommate selection freshman year.
I had to join Facebook to go to my 20th high school reunion because they were organizing it on Facebook. That was a while ago. All right, who votes for chess set is going to blow it out of the water? 1, 2, 3, 4. Be confident. I said you can vote for more than one. Be confident. 1, 2, 3, 4, 5, 6, 9, 10. Who thinks the hand card? Holy hand card fans. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Supercharger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is this like yoga? You just get better at raising your hands as you go?
I think Hand Crusher got more votes with the notion of voting.
Well, you do. All right, so we can re-vote on Hand Crusher, but after the puzzlers. Puzzles. Who thinks puzzles are gonna knock it out of the park? 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, you know, same both times. All right, revote on the Can Crusher. Better not be less. I'm not gonna count your hands twice. 1, 2, 3, 4, 6, 7, 8. All right, 8. What? It's just like fixing a grade on a test, right? Or sign it. All right, I think that's great. So what are we doing? We're meeting again on Monday, right? I hated Zoom the Monday that we met. I think I said that we would do Zoom on Mondays, but I hated Zoom. It sucked. Can we come here instead? Let's do in person on Mondays and on Thursdays. And I'll use the StreamYard, so there'll be a YouTube link for every Monday and every Thursday. And then if you're home and you want to interact when I ask questions, I totally see the comments people type is if I'm looking. So you can totally type your comments and we can interact. So if you can't come to class, watch the YouTube. Otherwise, let's be here. And then and be healthy. Take the stairs. This classroom is right at the top of the stairs that are right as you come in the building.